Hi everyone, my name is Davies. I'm a database administrator working at INRAE in France. And so we'll be speaking about the Rescuelog project, which is a monitoring system for lifeguards based on Shiny and other open source tools. So maybe you've already know Southwest France, which is well known for its nice and large sandy beaches, very well known for many activities such as surfing and swimming and other stuff. It's very attractive for tourists, and also I live here. It's a very nice place. But it's actually one of the most dangerous coasts in the world, with heavy rip current and shore break. There's surveillance mainly during summer with thousands of rescues each year, but we still have 20 to 30 fatal drownings each year. So until now, life-saving activity was collected on paper, so reports were a pain to make for lifeguards, and we were losing so much data. So we really wanted to make a digital data collection tool for better reporting and for also better research and science. So a colleague came and asked me, could you make a Shiny app that would work offline on the beach, but also allowing to get back into R for predictive modeling and reporting. So I felt pretty overwhelmed with all the technologies that would be available. So in the end, my answer was, sorry, I'm not working at Fincar, so I may need to find something else to collect the data offline while still being able to circle back into R for predictive modeling and reporting stuff. So this is where I discovered another open source tool called Open Data Kit, which is some field data collection software that works offline. You only need an Android device to use it. Data is ready to import into a database, and it plays very well with R and Python. So basically, you just need to define your form using an Excel syntax. You upload it to the server. The server makes a QR code that you can use with an Android device to upload form data to the central server. And I know we are in a Shiny conference, so you must hate Excel as much as I do. So this is why my main side project is to make a new Shiny app to design these forms using a graphical user interface. So this will be coming soon on GitHub, but it's not ready yet, I'm sorry. So back to Rescuelog, we equipped 80 beaches with Android devices so that lifeguards could focus on saving lives. And then the data was sent to our ODK central server for analytics. Then I developed a daily pipeline to import the data into a proper Postgres database, and also to some S3 storage for other type of inputs. All of this thanks to the amazing RU ODK package, which uses the API to extract data in a database-ready format. Then the data is used in a predictive modeling workflow to predict the high-risk days, which is of great value for lifesavers and for emergency services. And of course, these predictions are directly integrated into our Shiny app. This Shiny app, of course, is deployed through Skate that I presented last year, which is basically an open source Kubernetes Docker-based ecosystem to deploy Shiny apps without worrying about the sysadmin and IT stuff. The app is developed using modern tools, so Shiny Manager for authentication, Golem for the code, BSLib for the UI, and it has nice interaction with the database for daily and other weekly statistics. The users can play with plots, tables, other type of widgets and interactive maps. And they are also able to produce Quarto branded reports for specific sites and or specific time periods. So this was a great success. after 2 years, the live servers are using ODK and the Shiny app daily. They are giving a lot of feedback, and they are very engaged. And so we were happy to build a fully open source workflow that would be easy to replicate anywhere else, actually. And so this will be my take-home message. I really encourage you to try this Shiny ODK framework to combine the power of open data kits for data collection, and of course of Shiny for data visualization and reporting and modeling and other kind of stuff. You will have 20 seconds to scan the last QR code if you want to know more about this project, or you can also come and see me during the day. Thank you very much.
This is Airedale Hospital. It's in Keighley, West Yorkshire. It looks after around 220,000 people, and it has a lot of A&E visits each year. And the government has committed to rebuilding Airedale Hospital completely. And my team at the NHS, the strategy unit, are rebuilding that. So the question that I think about all day is, how big should hospitals of the future be? Not in terms of bricks, but in terms of demand for every type of hospital service. So we start with patient-level real hospital data. So actually, people going in, we know exactly what surgery, individual-level data. And we ask hospitals lots of questions about what they think is going to increase demand, so population growth, rising patient expectations, dealing with waiting lists, and what's going to decrease it, so moving hospitals to community. We collect that as ranges rather than a single number, and we do that because then we've got distributions. And if we have distributions, we can run lots of model simulations and look at the future, what we're going to expect. In terms of tech, it's quite simple. It's a Shiny app that the hospitals use to explore their data. Then the model runs in Python. And then at the end, they get a Shiny app to explore the results instead. And we make, because we're all statisticians, we really want it to be variable. We want them to think about probability. This is Tom. He looks really serious in this photo, and that's because he was the only data scientist in the strategy unit, and he built the whole model, both Shiny apps, 2 years ago. He's really smart. He's actually got a perfect 10-year record at Advent of Code, which is mind-blowing to me, and sometimes he does it in Haskell just for fun. So he's a really smart guy, but he developed solo. 2 years on, we're a data science team of 11, award-winning. We've got the code open source, and we manage one of the NHS's largest open source models. But this very much wasn't the plan. It's been quite a wobbly journey. So like I said, it really wasn't the plan. My boss described it the other day as like we were casually dating the model, and then overnight suddenly we were married with 3 kids. This was definitely not a planned growth. It sort of organically grew very quickly. And there are 2 main reasons that sort of force this rapid growth. The first one is Tom had a baby. Which is lovely for Tom, but was really scary for the project. Because at the time, it was just Tom. He built all the code. No one knew how to press go on the model. So there was this sort of panic of like, okay, we need to hire data scientists very quickly. So that was quite scary. And then the second thing that happened is we had our first hospital use the Shiny app and the model, which was great, but suddenly it was, okay, here's a bug. Can we have this feature? How do we do this? And they were all coming in really unstructured as well. So yeah, Tom was gone. No one knew how to run the model, and everyone was going, hey, this is great. Can we use it? And yeah, this is when I joined the strategy unit 18 months ago. It was quite chaos. I've got loads of stories I can tell you about this, but I only have 163 seconds left. So I'm going to tell you about the one thing that I think was the hardest thing about the last 18 months. But there's, like Colin said, it's all lies, so I'll tell you the details really later. So the challenge here is that hospitals have been using our model for the last 2 years. Some of them ran it years ago, and they need that to work. Fine, so we have to keep that static. But we're also pushing out new updates all of the time. So we've got to maintain these old models perfectly while pushing out new models. The way we've handled this is by moving to using sprints. Well, sort of sprintish. We do sort of 3 weeks. The first 2 weeks are dev. The third week is a bit of QA. We try and launch on a Wednesday. We mess the launch up, and there's a bunch of bugs, so we fix them quickly and get it done by Friday. And the idea is that by the 4th week, we can just have a bit of a week to chill and just take some space. So sprints has been great to help manage expectations. partly because, when people say, can we have this feature, rather than say yes, yes, and burn ourselves out, or say no, we can say no, not yet. And we can also try and put tech debt in as well into our plan. However, the last time we did a tech debt sprint, it failed completely because someone said, we need this now. One thing I think has really helped is we use a single version for the whole ecosystem. So rather than have all of the apps sort of versioned independently, we say, look, this Shiny app, this model, it's all version 4.2. And when we do a release, we release all of the things at once. And that just keeps the comms really easy. We've also created some tiny Shiny apps, which we call switchboard apps. And basically, if a hospital comes in and they want to explore their data, we need to make sure that we show them the correct version of the app, because they might have run their model years ago, and they need the outputs app from version 0.1, or they've run the latest model, right? So we need to make sure we show them the right version of the Shiny app. So we manage that. QA, when you've got loads of versions, is really, really important, because every time we change the model, we need to make sure that we haven't broken anything. And hell no was I going to do a spreadsheet with colors, so everything is in GitHub. So all of our QA process in terms of checking what works is all on GitHub, and we can keep track of that. And finally, the code that was documented was really good that Tom wrote, but the methodology around the statistics wasn't really there. So we went for putting it all in a big Quarto website, so all the methodology is actually versioned and published alongside the code, and we write it up and share it with our sort of hospitals and stakeholders. So if I'm being honest, the hardest thing in the last 18 months hasn't been building Shiny modules or writing stats, even though there's been plenty of that. It's been designing processes that will help us develop in production confidently. And honestly, we haven't quite worked it all out yet. I'm Rhian, thank you.
All right, so earlier this year, we had a work week and we asked some teams at the company, what experiments would you like to have inside with LLMs and Gen AI and so on? And many teams came to me with examples of requests. One of them was from a finance team. Of course, we know about Elmer, you know about Shiny Chat, you build a simple app, you connect your database to your data, and the user can ask questions. And this code is of no relevance at all other than it's a typical outline of a Shiny app. And of course, your users love it. And so did mine. They asked for more. And I realized that that single app just for finance was helpful, but it's even more helpful if you combine multiple data sources. So for example, if you combine information from Salesforce with information from Zendesk and your product database and so on, it becomes much, much more valuable. And it's also not something you can buy off the shelf. You can buy off the shelf solutions for any specific one, but you haven't factored in information security. So my name's Andrie. I'm a product manager at Posit, and I'm going to talk a bit about how to work with InfoSec, the team, information security team, to get your Shiny app into production. InfoSec cares about three things. This is three oaths they swear, apparently. Availability, integrity, and confidentiality. And you see some nods. Availability is what they care about. Do the servers run with Six Sigma reliability? Integrity, is the information correct? Is your Shiny app working correctly? Is the information true? And confidentiality, are you exposing the data only to those people who should care about it? And so they're going to care about multiple risks. Let me name a few. One is that it's data leakage. So this is about confidentiality. All of these things you have access to, and some of this is really of high importance if it leaks. Trade secrets, personal information, confidential customer information. You don't want to expose any of this. Your second risk is that you don't test, and especially if you have an AI in the mix, if this AI ingests answers and you then write that back into some production database again, you are going to set yourself up for real trouble. And also, if you don't write it back to production, then you're on the risk of data silo. So you're a bit of a bind here. And the third one is much more subtle, is the accidental risk of exposure of your secrets via the model itself. So you you're connecting to ChatGPT or Claude or whatever model you're using, and InfoSec is going to be concerned that your data is going to be used to train and improve the model, and then in that way accidentally leak your information. Now, I'm not here just to talk about risks, but also about some solutions, and I don't have all the answers, merely some suggestions. The first one is, well, just make sure that you work with your InfoSec team and consider at least these things. They'll come up with a much longer list. Authorization, make sure you have minimal permissions on the information. If you extract information from, in my case, from Salesforce, you don't want to expose that information to people who don't have Salesforce access to you normally. So limit your audience to trusted users. Make sure that your data is secure. So host your models within guardrails. So internally, we use AWS Bedrock. So AWS takes care of that for us. It's a trusted model. They guarantee that the data does not go to in this case, Anthropic or OpenAI. Your IT team may have something else. And the third one I alluded to earlier is use scoped permissions. So make sure that you only expose the resulting LLM data to people who have access to the underlying data in the first place. Most importantly, don't ask for forgiveness, ask for permission. Go and speak to your IT team earlier and tell them what you have in mind, and as soon as you can. And I know some of you can build amazing solutions because your IT team are forward-looking, and some of you told me you're completely and utterly blocked. A good IT team will actually try and enable you, not block you. So take the time, make friends. Yeah, I see some mixed reactions, but make friends with them and build it.
Today's talk is not a particularly technical one. I am a little concerned, for those who were in the workshop yesterday, that I might overrun a bit, because I do have a tendency to talk a bit. What we're talking about is discoverability today. Jumping Rivers do all manner of things, and you'll see adverts like this out in the foyer and things like that. Training and solutions and things like that. I'm more on the app development side. And for a lot of the clients that we work with, the issue that they face when it comes to us is the kinds of things that are on the right-hand side here. This button isn't working. How do you work this thing? What does that result mean? That's the things that their users are asking them when they work with an app. And they're the kinds of things that we tend to fix, but sometimes they're not the things you need to fix. If you've got an application, you're working in a big organization or something like that, unless people know where to find that app, know how to start it running and things like that, they can't use it. And that's the thing that you need to solve for them. In software development, we have something crops up in a similar way. If you've got a package that you've written or some functions and things like that, if people can't find it, or it's poorly described, they won't use it, and they'll end up implementing something themselves and things like that. And that counts exactly the same for data sets and for spreadsheets and reports and applications and things like that. Yes, so specifically for applications. For Shiny apps, in Jumping Rivers, we've deployed POSIT Connect for many clients now. This is like a solution for deploying things. Within it, you can put things like descriptions that your users can kind of search through, tags to tell them what team things have come from and what it relates to and things like that. You can, within an app, you can document what it's for, and you can give things a vaguely memorable URL rather than the kind of random URLs that you get. Now, there are many other solutions for deploying Shiny apps and Flask apps and things like that. And yeah, there's across data science, there's many different types of deployment. What stage is an app at, and where is it deployed? How do users actually use it? Do they email your team and ask you to do a query for them? Or do they access the app themselves and ask those kind of questions? And yeah, so one thing that you can do to simplify their life is help them find your products, help them find your data sets, help them find your applications and things like that, so that at least they know the right people to ask, or they know the URL to chase to ask questions themselves. And that can be as simple as just putting a spreadsheet on like a shared drive or something like that that says, our team controls such and such applications and data sets and spreadsheets. Here's the person responsible, here's the URL and things like that. But we're in a Shiny conference today. So you could quite feasibly make an app for that and direct people to your app if they want to find the products and things that you've made. As an example of the kind of thing, and it doesn't have to be particularly complicated, we have put together a gallery on the Jumping Rivers website that demos some of the kind of types of dashboards that we've built, the types of Shiny apps and similar things that we've built. And it's quite simple to put something together like this. It's a single page with screenshots and links to various apps. If you follow the QR code, you can get to it, but you can get to it through our website anyway. On there, we have a range of things. Some things that are deployed on POSIT, a mapping application, some dashboards. Some things that are deployed as like single pages within our website. And if we didn't have something that kind of integrated all of those applications, it'd be quite hard to find the right link to find, you know, the history of R and things like that. We've got some fancy features in there. If you get a chance, have a speak to Tim, who's going around doing the photography. He built this part of the website for us, and it does things like, you know, you can launch apps within the page itself and launch them so that they run in full screen and things. The complicated aspects of the dashboards that are on there and the website itself were built by these three people here, and I kind of just oversaw what they were doing. Anyway, yes, that's it. Thank you, everyone.
Thanks, really. Thanks for having us. Yeah, I'm good. It's Euan, and today we're going to talk about how we, as a small but fiction charity tech team, built an app with Shiny to connect the supply and demand of biodiversity credits in Kent. So a little bit about us and what we do. So we're the development team, and our backgrounds are in GIS and environmental science, and with a little bit of our experience previously. But nowadays we're pretty much become Shiny developers. These are sort of things we've built. And we're going to focus on one of the first apps that we made when we were sort of beginners. I did slightly cheat and make these 40 seconds long and slightly regretting it now.
It's worth it.
Not in everyone. But surely. So I'm going to go into the app a little bit. What is BNG? So in 2024, the government brought in a new mandatory policy where developers or any large-scale developers have to increase biodiversity by 10% or more. And one way that developers can do that is by buying biodiversity credits from habitat banks. And with so many faraway banks available, local authorities, they came to us wanting a solution to encourage developers to invest locally and improve the sort of make sure that environmental and financial benefit was felt. within the county, which is where the idea for a right move for BNG came about. So this is where one of the using the app where developers can see all of the habitat bags in Kent. They can filter by habitat type, number of units, and once they found a habitat bag that has what they need, they can make a direct inquiry through the app. And this is what you would see as a habitat bag provider. Here you can add your projects, you can upload the BNG metric spreadsheet, the sort of mandate spreadsheet, and you can edit, delete, make any edits to your project and everything.
So we used a number of different UI packages. For instance, BS4 Dash gave us the nice dashboard layout. We used Leaflet for the open source mapping, and DT took care of the tables. And we were able to extend the functionality a little bit with snippets of JavaScript. For instance, like making links in table rows that have actions specific to the row. And user authentication is a really important part of the app. And what we went with was Auth0, which is like a freemium service for users to sign up by themselves with their email address. And that was really simple to set up with the Auth0 R package, which also allowed us to have email verification. And it was really important that we kept our PostgreSQL database with the data in it secure. So we used Glue SQL to construct SQL queries and prevent SQL injection attack. And we used Input Validator to sanitize user inputs in a user-friendly way. And we also have role-based access in the database. And bringing all this together into one Shiny app was a challenge, but Golem, the app framework, really helped there. And it showed us how to modularize the code, leverage namespacing, and the added benefit was, because it works as an R package, we learned how R packages work under the hood. So we're even able to make our own R package that's not a Shiny app, and this deals with a key bit of business logic, extracting the metric values from the spreadsheet, which actually ended up being quite complicated. So having tests with TestStat and documenting it was really important, and it means that we're able to use it in other BNG projects. And the clients that we're working with wanted us to have their custom branding, so we added our own CSS. We used the browser dev tools to find the right class names so that we could override those rules and adjust colors and fonts. And we also used a bit of Shiny.js to dynamically add and remove CSS classes for a bit more responsiveness. And obviously we love reactivity provided by Shiny, and the pattern that we used for the map and table linked to filters was render UI and event reactive. We also have hidden tab set panels which allow for a lightweight routing system. But the reactivity in Shiny is so sophisticated, you can actually kind of make the wrong choices. And initially, we had too much observers going on, and that was leading to unnecessary re-renders. But the Rescuelog package helped there, and you can observe what's going on under the hood and make any changes.
So to use Alexa, the app is performing well. We've got almost 500 users, 44 habitat bags and 5,000 credits, which is almost 200 billion market value in theory. So beyond the site register, Shiny was a really good sort of gateway drug into general web development for us. It kind of let us see what was possible in web development from the comfort of the language that we knew a little bit about, and has led to exploring other web development tools, but we're still very much well on Shiny for sort of any data science-y, dashboard, data-focused portals. So yeah, thank you.
Thanks, everyone.
My name is Natalia Petersen, and I'm here today from the National Disease Registration Service, which is part of NHS England. And I'm going to be talking to you about a hackathon day that we had as a team for developing the Cancer Treatments Shiny app, which should, I think that's been 20 seconds. So a little bit about the publication itself. So it's a publicly available dashboard that presents treatment data for radiotherapy, anti-cancer therapies such as chemotherapy and tumour resections for patients that have been diagnosed with cancer in England. It's published annually. This is how the app used to look. So it was previously 2 separate apps, one for demographic factors and one for breakdowns by geography. So yeah, you might agree it looks a little bit retro. So I'll talk to you a little bit about the development work that we did on this. So it's for a variety of audiences, so stakeholders such as charities, clinicians and patients themselves. So this is a really simplified kind of representation of what the process looked like, but just to highlight kind of what we were focusing on. So one of the things we wanted to tackle was that our code was really repetitive. The code had lots of repetitive bits of code that just made it really difficult to follow, and every time we added something new, because it was an iteratively built publication year on year, there was loads of different places we had to add the code in for each output. Another thing on that note is that we then developed a lot of if-else statements where when we added, whether it was a new cancer site or a new piece of functionality, we'd kind of shoehorn it in as, represented as square stuff into our round pipeline. So it just got more and more complicated, more and more lengthy, more and more difficult to debug and keep on top of. But we just didn't have the time to rewrite the whole pipeline. And secondly, the whole thing was basically run twice because of the 2 separate apps, so with only really minor differences. So we wanted to address this repetitiveness also across the 2 processes. So the way we decided to approach that was just to have a hackathon day as a team. We had 4 tasks, 4 hours and 4 analysts, which wasn't deliberately planned that way, but it's satisfying when I realised that for this talk. And yeah, each of the kind of overarching tasks was trying to target one of the issues that I mentioned on the previous slide. Cool. So jumping forward, those 4 hours, we achieved loads. We now have 1 app script, which I'm really pleased to say, and 1 app. So we've reduced that duplication massively. Bit of echo. We also have developed, not as part of this day, but we utilised an internal NDRS Shiny template that we have. We've also modularised the code, so 1 app script, and our simple as possible functions are called in from each of their own separate scripts. Nothing is updated in multiple places anymore. We have 1 global parameter script, and we use lookups now, which maybe isn't ideal, but much better than all our lengthy if statements. We also have standalone text files that are also called into our main run script. NGRS themes and accessible colours are applied to the app, and we've also standardised, so the data is also downloadable, and that is now based on the same code that builds the plots and outputs. Just wanted to share a few reflections as well of what we felt made this super successful. We all got together as a team in person, and yeah, I'm sure you'll all agree because you're here that that's just so valuable, and we found that really important to have that protected time where that day was just that project, which doesn't happen that often. We were also really prepared in that we had prerequisites that we each had to do so we could arrive and really hit the ground running when we got there on the day, and we each knew what we were expected to do as soon as we got there. And a lot of thought was putting into making sure no one was twiddling their thumbs, no one was depending on someone else finishing something so that they could get started. We also thought about what each individual would like to achieve from that day, whether they wanted to learn a new skill or develop existing ones. And all of that came together to put together achievable objectives. So we tried to be challenging and challenge ourselves at what we could achieve, but also really realistic about what we could do in one day. We did, on that note, agree that we would have maybe liked a hackathon day 2, particularly to tidy up the code, but we did have some dedicated mop-up time remotely, so it's all more tidy, really well documented. And yeah, one of the things as a team we're really trying to do is to make all our pipelines as reproducible, transparent, robust as possible, and it shows to demonstrate that we can implement principles of reproducible analytical pipelines in our working practices as a big organisation. And this is just a screenshot of the new app, which hopefully you agree looks much better. And yeah, we've now got the demographic and geographic as tabs, which were the 2 previous separate apps. and then the subtabs for the various breakdowns. And on the next slide, there is a link and also a QR code to the GitHub repository. So all of this code is publicly available. So if you'd like to go and have a look, also would love any feedback. And thank you very much for listening.
Thank you.
Hello everyone, my name is Andreas Wolfsbauer. I'm a data scientist at AGES, the Austrian Agency for Health and Food Safety, where I work at the Institute for Surveillance and Infectious Disease Epidemiology. And today I'll be talking about how I developed a Shiny application for standardized data analysis. So first, a bit of context about AGES. We're a public health agency based in Austria, where we work to detect and manage the risks for humans, animals, plants, and the environment in the sense of a One Health concept. So our areas of expertise range from medicine safety to food safety and environmental threats. And in our institute is within the public health department. So we focus on outbreak investigation, national disease surveillance, and data-driven modeling of the 76 notifiable diseases that we track in Austria. So in the past, epidemiologists have been using Excel for analyzing case data and visualizations, which led to a lot of repetitive manual work. So to help with that, I developed an application to provide them with standardized plot and quick access to current case numbers. So the app consists of two main components. One is a dashboard where users can load a disease data set and filter on year, state, and age group. They have visualizations that are interactive with Plotly. They can download these plots and the underlying data, and they can generate a PDF report. And then the second big part of the app is like an analysis page where they have advanced filtering options with data table. They can then aggregate and pivot this data in another data table and download both as a CSV file, or they can use the filter data to make a custom plot by selecting the variables and customizing the title, caption, and a lot of other things. Then there is also documentation, which is pretty self-explanatory, I guess, and a news and a feedback module where I have a changelog and what features I'll be talking on developing next, and so also a feedback module so they can give me feedback what they want to see next. So our user base at the Institute is 24 people, which doesn't sound like a lot, but our Institute is growing and I'm adding more functionality to the app. So it was really important for me that it stayed responsive even with concurrent users. And as I mentioned before, in our institute, we rely a lot on Excel because that's how we have access to the case data, sadly. So I made a scheduled job preloading the data in the morning and saved it as an RDS file and let the app run continuously. So it preloads the data in the morning, and that really helped with the performance. But the next step was how could I increase availability? And since we're a governmental-owned company and we're dealing with sensitive personal data, it can't leave our servers, so we have to self-host. And with self-hosting, I was constrained. I could only use Shiny Server open source. So my IT department didn't allow me to use Docker, which meant I couldn't use Shiny Proxy. And Shiny Server open source gives you one process per app. So what I ended up doing is I deployed my app 3 times, but that led me to the problem of how can I distribute my users across the app instances. So what I ended up doing was writing a custom gateway app that handles load balancing. It assigns the users to the least busy instance with a token. And that token is stored in a shared JSON file. And the app instances verify the user tokens and update the user counts in the JSON. So in the future, what I want to do is relocate data storage outside of the app, maybe to be loaded with scheduled jobs on the server. Or look at alternative formats of data storage. I want to try asynchronous programming, maybe, or I should, as we learned today, use some tests. And from the user side, I want to implement a starting page that gives an overview of long-term trends so users can select the disease that needs an attention. and an information page that provides seasonal trends. And I also want to extend the analysis module, provide more plotting options. So yeah, developing this app really taught me the importance of understanding the user's needs. So making an app that they actually use. I had to learn the hard way that I should write my code modular and efficient. I had to refactor my app 1 or 2 times. And the technical improvements that mattered most were the data preloading and increasing the availability of the app. And it really increased the workflow in our institute. And it has been an ongoing learning experience for myself. It's been my first big Shiny application that I've developed. Yeah, thanks for your attention. If you have any questions, feel free to contact me, or any tips even, how I could improve my app. Yeah, thank you.
Thank you.